All right, let's move on to item number 21. Gerson has a can of soda with height equal to its diameter, which is 48 cm. What is its volume? Is it A, B, C, or D? And I hope we could still recall the formula for the volume of a cylinder. That is V equals pi r squared h, where r is the radius of the circular base and h is the height. In this case, since the height and diameter are both equal to 48 cm, so your height is 48, but we need your radius. So 48 divided by 2, that means our radius is 24. And by substitution now to this formula, we have V equals pi times 24 squared times 48. 24 squared means 24 times 24, or that's 576. And multiplying pi, 576 and 48 gives us 27,648 pi centimeters cube. Letter A. Okay. Next one. 22. Solve for x in the equation 2 quantity absolute value of x minus 4 minus 7 equals 5. Is it negative 2, 10, 2, negative 10, negative 3 and 7, or negative 4 and 8? We could expect here that there are at most 2 answers here. For this one, copying the equation, I need to isolate the expression containing the absolute value only. Hence, I need to add 7 both sides first. So we have twice the absolute value of x minus 4 equals 5 plus 7, which is 12. Also, I would like to divide both sides by 2. And with that, we have the absolute value of x minus 4 is equal to 6. And remember, we could actually, we could see here that the absolute value of x minus 4 is equal to a positive number here. Hence, we could apply the property that the x minus 4 could be equal to the positive value. That's why x minus 4 is 6. Or the absolute, or x minus 4 should be the negative of this. That's why we have x minus 4 equals negative 6. Adding 4 to both sides of each of these equations. For the first one, plus 4 here, you have x equals 10. For the second one, adding 4 both sides, negative 6 plus 4 will give you negative 2. Hence, the value of x that satisfies these equations are negative 2, and we have your 10 as well. Letter A is the correct answer. Okay. Moving on to 23. What is the sum of the first 15 odd numbers? So is it 130, 160, 169, or 225? In our case here, there's a presumption that the odd numbers are positive, okay? So from here, we could actually solve this in many ways. We could use finding a pattern. Like if you have only one number, so it's just 1, but 1 is 1 squared. If you have 2 odd numbers, the first 2 of them, 1 and 3, so 1 plus 3 is 4. But you could see that 4 is in fact the square of 2. If you will get the sum of the first 3 odd numbers rather, 1 plus 3 plus 5, that's 9. But 9 is 3 squared, right? Hence, in other words, the sum of the first n odd numbers has to be n squared. And since we're looking for the sum of the first 15 odd natural numbers, then its sum based on the pattern is 15 squared, or 15 times 15, which is 225, letter D. All right. 24. What is the 9th term in the sequence 2, 7, 12, and so on? Is it 37, 42, 47, 52? What do you think? You could actually see that from 2 to get to 7, you add 5. From 7 to make 12, you add 5 as well. So this appears to be an arithmetic sequence with first term 2. And that's why a sub 1 is 2. And the common difference is 5. And I hope we could still remember the formula for the nth term of an arithmetic sequence. That is, a sub n equals a sub 1 plus n minus 1 times d, where a sub n is the nth term, a sub 1 is the first term, n is the number of terms, and d is the common difference. Our common difference here is positive 5, not negative 5. It's positive because the sequence is increasing. We're looking for the 9th term, so we're looking for a sub 9, and substituting n by 9, a sub 1 by 2, and d with 5, we arrive to 2 plus 9 minus 1 times the quantity 5. 9 minus 1 times 5. So this becomes 2 plus 8 times 5. The 8 times 5 is 40. So 2 plus 40 gives us 42. Hence, the correct answer here, the 9th term of this arithmetic sequence is 42, letter B. All right. 25. A fraction is equivalent to 3/4. Subtracting 1 from the numerator and adding 2 to the denominator. Okay, sorry, this should be denominator. And adding 2 to the denominator results to a fraction equal to 1/2. What is the original fraction? Is it 12/16, 6/8, 15/28, or 3/4? You could actually do this by trial and error. You could actually do this using trial and error by guess and check. But for now, the one that I will be giving you will not involve guess and check. So let's say, let x be the GCF of the numerator and denominator. And since the ratio in simplified form, that's 3:4, so we will have it 3x is 2, or 3x over 4x be the original fraction. So subtracting 1 and adding 2 to the denominator, we have 3x minus 1 all over 4x plus 2 equals 1/2. By employing multiplication property of equality, or like what they say, cross multiplication, so the product of 3x minus 1 and 2, which is 6x minus 2, is equal to the product of 4x plus 2 and 1, which is 4x plus 2. Subtracting both sides by 4x and adding both sides by 2 to isolate the terms containing the variable and the constant, we arrive to 2x equals 4. And dividing both sides by 2, we get x equals 2. And remember, the GCF, x here is our GCF. And hence, to get the original fraction, which is 3x over 4x, we will multiply both numerator and denominator by 2. And that's 3 times 2 all over 4 times 2. And that is 6/8, which is our original fraction. Letter B. Next number, 26. The third term of an arithmetic series is 13, and the 7th term is 37. What is the 51st term? Is it 257, 295, 301, or 313? What do you think? To answer this question, we can actually utilize the formula for the nth term of an arithmetic sequence. That is, a sub n equals a sub 1 plus n minus 1 times t. So since the third term is 13, we could substitute n with 3 because it's the third term. That's why replacing all n's with 3, you will arrive to a sub 3 equals a sub 1 plus 3 minus 1, that's 2 times d, that's why you're 2d. That's why the third term is a sub 1 plus 2d. But since it's specified as 13, that's why we have here equals 13 as well. Now, for the second one, the seventh term is 37. So we will replace n with 7. So that is a sub, replacing all n's by 7 here, we have a sub 7 equals a sub 1 plus 7 minus 1, that's 6 times d, 6d equals. So the seventh term is a sub 1 plus 6d, which is 37. And upon doing such, I arrive to equation 1 as a sub 1 plus 2d equals 13. And equation 2 as a sub 1 plus 6d equals 37. Now, what are we going to do next? To eliminate a sub 1, with the intention of eliminating a sub 1, I am going to subtract equation 2 by equation 1. By doing such, a sub 1 minus a sub 1 is 0. 6d minus 2d is 4d equals 37 minus 13, which is 24. Dividing both sides by 4, you get d equals 6. All right. But we are not yet done. Knowing the value of d, which is 6, we can look for the value of a sub 1 by substituting it either in equation 2 or in equation 1 or in equation 2. In my case, I opted to substitute it to equation 1, which is a sub 1 plus 2d equals 13. Replacing the d by 6, I arrived to a sub 1 plus 2 times 6 equals 13. 2 times 6 is 12, and subtracting both sides by 12, that tells us that the first term is 1. And now, since we have the first term 1 and common difference 6, we can now determine the 51st term by replacing n with 51 and utilizing the values of a sub 1 and d. And a sub 51 is equal to 1 plus 51 minus 1 times d, which is 6. 51 minus 1 is 50. The 50 times 6 here simplifies to 300. Plus 1, that gives you 301. And the correct answer is C. And I hope you got this as well. 27. Using the digits 1, 4, 5, 7, 8, and 9, how many 4-digit even numbers between 5,000 and 900,000 can be made if repetition of digits is allowed? Now, is it 216, 729, 891, or 900? If repetition of digits is allowed, so we could see this one. How come? If it's between 4,000 and 5,000, I mean 5,000 and 9,000, this tells us that the number could begin with either 5, 7, or 8. It could not begin with 9 because in this case, if it begins with 9, it will be more than 9,000. So there are 3 choices for the thousands digits. And since we have 6 digits here, and they could be used in the middle, that's why we have 6 for the hundreds and 6 possibilities for the tens place. The number has to be even. Hence, it should end with either 4 or 8 in this case. That's why we have 2 here. And by the fundamental counting principle, we have to multiply 3, 6, 6, and 2, and that gives us 216. And that is letter A. I hope you got letter A as well. Okay. 28. A ball bounces at a height of 1,296 cm, and each succeeding bounce is 2/3 of the former. How high is the fourth bounce? In centimeters, is it 768, 256, 256 thirds, or 256 ninths? What do you think? To do this, it's important to get how high the first bounce is. The first bounce, it says now that every bounce is 2/3 of the former. So if the height, if that was dropped, is 1296 cm, 2/3 of that is 864. Meaning to say, the first bounce or our A sub 1 is 864 here, and our common ratio is 2/3. We also know that the formula, that since you have a common ratio of 2/3, then this tells us that we are in fact using the concept of the nth term of a geometric sequence, whose formula is a sub n equals a sub 1 times r raised to n minus 1, where a sub n is the nth term, a sub 1 is the first term, and r is the common ratio, and n is the number of terms. By substitution here, we're looking for the fourth bounce. So a sub 4, we will replace n with 4. So that becomes a sub 4 equals a sub 1 times r to the n minus 1, 4 minus 1. So it should be 4 here yet. All right. And with such, you arrive to a sub 4 equals 864 times 2/3 raised to 4 minus 1, or 3. So 2/3 cube will be 8/27, and multiplying that with 864 gives you the fourth term, or the height of the fourth bounce, which is 256 cm. And that is letter B. Okay. Number 29. What is the area of a square in centimeters squared whose diagonal is 20 cm, 150, 200, 250, or 280? What others do is that they look for the value of the side of a square using the Pythagorean theorem, or of that of the 45, 45, 90 triangle. No problem. But there's actually a shortcut, that is, to get the area of a square given the length of its diagonal, it's simply d squared, or the length of the diagonal squared, divided by 2. And applying the formula, that's 20 squared over 2, and you get 400. 20 squared over 2, 20 squared is 400, and 400 over 2 is 200 square units, letter B. But if you did other methods, it's okay. But at least you have an alternative on how to do it the faster way. 30. What is the limit of the square root of x minus 3 all over x minus 9 as x approaches 9? Is it 160, negative 1/6, or 1/9? If you could see, if you substitute 9 to both numerator and denominator, square root of 9 to the x rather, square root of 9 is 3. 3 minus 3 is 0. For the denominator, 9 minus 9 is 0. So you have a 0 over 0 indeterminate form, right? That's why, if this is the case, you could actually employ L'Hopital's rule. You could also employ multiplying both numerator and denominator with square root of x plus 3, and you will see why. We will multiply. Doing this simplifies the numerator. Square root of x times square root of x will be x, and negative 3 times 3 will be minus 9. The product of your numerator will be x minus 9, and your denominator will become x minus 9 times the square root of x plus 3. You could see I did not actually give the product of the denominators because my intention, I mean to simplify it by FOIL method, because my intention is to cancel the x minus 9s in both numerator and denominator, because they are, x minus 9 is a common factor. Dividing both numerator and denominator by x minus 9, you get the limit of 1 over the square root of x plus 3. And now, as x approaches 9, we will substitute x by 9, and we will get 1 over square root of 9 plus 3. Square root of 9 is 3. So the denominator becomes 3 plus 3, which is 6. Hence, it's 1/6. And that is letter A. I hope you got letter A as well.